right, so we're going to go into what the chemical equation is. And so what we have here on our little slide, we have some examples of a chemical equation. And so we had talked about in Unit 1 what it means for chemical change or chemical reaction to occur. You know, we have formation of precipitate, change in temperature, color change, evolution of a gas, all those things. And so when we are looking at how to write those changes out, we're going to use these chemical equations. And so we have our reactants, and sometimes energy goes into them, and we get products. And you can see here that we have these little L's and G's and all this, and those are state symbols, liquid, solid, gas. And we have aqueous as well. And so if you are looking at an equation and it has an AQ beside it, that means it's dissolved in water. And so I was telling you guys that if I have an ionic compound, like let's say I have sodium chloride, right? And I know that when you see that, you think, okay, that's one sodium and one chlorine, and that's right. Really one sodium ion and one chloride ion. But when you draw this, it's actually a big kind of crystal. And so it looks more like this. It's in a big cube, like this cube here. So when they dissolve in water, what ends up happening is the water will come in and it will actually break. When something dissolves, it doesn't disappear, right? What ends up happening is the water will come in and it will tear this apart. So this is sodium, chlorine, sodium, chlorine, sodium, chlorine. Oops. It will come in and I think I say consistent. The water will actually come in and it will, the hydrogen side is a little bit positive and the oxygen side is a little bit negative. And it will actually kind of tear these off and they'll go floating around in the water. And so just for clarity's sake right now, here's some water. If I was to put this in the water, let me get a different color. There we go. If I was to put that in the water to make it aqueous, they would actually separate out. And so I would end up having like an ion floating around separate from the other ion. And this would be water surrounding it. And that is a whole unit and a whole topic that we're going to go into and how that happens. So I don't want to like bog you down right now. But aqueous means it's in water. Yes, ma'am, sir.
Didn't we learn that when something's dissolved in water, that was physical change?
Yes, but here's the thing. If we had sodium chloride and we put it next to magnesium bromide, and we just put those two solids right beside each other, do you think anything would happen? So guess where that happens? It has to happen at? In water. Because that will break the ions apart from that crystal, and that will allow them to rearrange. And so when we've had something like that precipitate form, when we did, and we had that solid yellow lead iodide, do you remember that? So if I just put those two powders together, nothing would happen. So I have to put it in water for the ions to break apart so that it can rearrange. Okay, so that's what's happening. Does that kind of answer your question? All right, so yeah, dissolving something is a physical change. There's like this school of thought that kind of argues that. I don't want to get into it. But anyway, solid and gas and liquid, these are pretty easy. This means it's in water, no problem. So if you think about aqua, meaning like water, AQ shouldn't be, you know, that much to think about. Plus means they're going to, these substances are coming together, crazy talk. And then this arrow is really, you're going to say yields or makes, but I like yields better. So if we look here, of course the reactants, sometimes they're called reagents. Did we talk about reagents yesterday a little bit? Yeah, reagents are also reactants, and they will yield products. So if I'm looking at this, these are my reactants, and they yield, so methane and oxygen gas yield water and carbon dioxide. Now, you should already know what kind of reaction this is. Is this ringing a bell for you? If you saw that, what would it be, everybody?
Combustion.
Combustion, good. All right, now, this doesn't have those state symbols, so let's add them. This is methane gas. So this is what you cook your food with. This is natural gas. So it's probably gas, right? What state is oxygen in? and it actually yields water vapor as a gas. Water can be a gas. That's how clouds are made. Water vapor rises, and then it condenses into a liquid, and that's where clouds are liquid water. But anyway, got up there. And then carbon dioxide gas. And so these state symbols aren't going to be as important in this class as they are in future classes, but it's a heaven or hell issue later on in chemistry if it's a gas or a solid or a liquid. Sometimes I don't even want to get into it, but it's just like it could change how you do everything and it'll mess up all your answers. I'll just trust me on that one. So those state symbols can be used to kind of clarify what state everything's in. So anyway, when we look back at the do now, our warm-up, I see that I have two chlorines and one magnesium on the reactant side. And then I also have two chlorines and one magnesium on the product side, two fluorines on the reactant side, two fluorines on the product side. So if I go to balance this equation and I end up with something like this, have I created matter? Like I put this into the reaction and I got this out. Is matter conserved? Is mass conserved here? So that's the whole issue, right? We have to make sure that what goes into the reaction is what comes out. So this will weigh as much as this, and this will have the same number of atoms and the same type as this. And so that's the law of conservation of mass. It states that the mass of substances must be equal to the mass of the products, and that there has to be the same number of atoms on each side. So anyway, in order for this to happen, you have to change the coefficients. You're not going to change. The subscripts or anything. So let me give you this. Here we have water. We have hydrogen gas and oxygen gas making water vapor. So if we go back to the board, and I want to draw this for you. Notice how these are diatomic. And if I draw these out for you, I'm going to use this light blue for hydrogen. And I'm going to use the red for oxygen. So is the law of conservation of matter, is it being demonstrated here?
No.
So if I want to balance this equation, or make sure that I have the same reactants as products, what do I need to, what do I need more of? I have two hydrogens, two oxygens, two hydrogens, one oxygen. So can I just,
No.
how does do that?
No.
No, that's not water. My reaction, when I'm looking at what it's telling me, it's telling me I'm making water. This is hydrogen peroxide. H2O2 is hydrogen peroxide. You ever heard that joke? Two guys walk into the bar. One asked for H2O, one asked for H2O2, the other one died.
Yeah.
That's hydrogen peroxide. So I don't think that's exactly what the structure looked like. So I'm going to have to add not just a hydrogen or an oxygen, but I'm going to have to add a whole another water molecule. Now is this balanced?
No.
So what do I need more of?
Hydrogen.
So the balanced equation here is 1, 2 hydrogens, 1 oxygen. I don't need a coefficient if it's 1. And then 2 waters. And that's what those numbers really mean. Okay? So can't make a new substance as far as, you know, what's called for. If I can't just do this, I have to make a whole, I have to get a whole nother water. Let me make that go away. That's making me sad. So anyway, write this down. You're going to do that. You don't do this. You don't do what I just did. Don't do that. And that just looks silly. But people do it. People do it sometimes. That would be easier, I think. Okay, so moving on with our lives. Hydrogen gas and oxygen gas combine to form water. Remember your Mr. Brinkelhoff, right? Your bromine iodine nitrogen, chlorine, hydrogen, oxygen, and fluorine. So when we're looking at this, another thing that's very tempting to do, people will take, they'll be like, hydrogen gas. And that really is that, right? Ooh, it like erases the whole circle. Look at that. So hydrogen gas and oxygen gas give me water. That doesn't even look right, does it? But people do it. People do it. So make sure if you have a diatomic element, hydrogen, oxygen, and I showed you guys how it made a 7 on the PR table, right? The 7 that's there, and then your hydrogen. So don't do this. Do that. Don't do this. When you write this, it should make your eyeballs hurt, like you want to wash your eyes. Oh, that don't look right. So don't do that. You're definitely missing some things here, right? That kind of makes you sad when you look at it. I get sad when I see stuff like this. Oh. So those things are never found alone. They're going to have the 2 here and a 2 here, and then we'll have to go in and bounce like I showed you a second ago. Happy times? Moving on. Okay, so what I want you guys to do is I want you to get your whiteboards, and I want you to draw out these, and I've given you enough colors to do so. So I want you just to tell me, first of all, if it's correct or not. And then if it's not correct, I would like you to use your whiteboards to correct it. So start at the beginning. I want you to draw me the particles. If it's correct, you draw it and then put yes. Now, some of these have been written incorrectly. Some of the ionic formula units are not neutrally charged. Some of them are the compounds themselves are not. Yes. Do you see a compound in number 4 that's maybe not neutral? Look for it. I'll give you that hint in number 4. What is it? Huh? The lithium is 1+ and oxygen is 2-. Look to the next one.
Magnesium bromide.
Yeah, the magnesium bromide. So be careful with that.
Good to draw now.
You have lots of colors and markers to choose from, so use your easy. I should see you drawing these, and then you can count your different elements to make sure that you have the same on each side.
So we're drawing them out.
Yeah, so you're drawing them out. So after you draw them, you can continue adding more shapes to bounce. So I'll do the first one up here. This is on your PowerPoint if you need to reference that. Y'all remember ammonia is that trigonal pyramidal? Do you remember?
Yep.
I remember.
Say if it's not correct.
Yeah, if it's not correct, correct it. So as I'm looking around, just to give you an example, this is what I should see for the first reaction. Then I can count my hydrogen atoms. Are they the same on the reactants and products? My nitrogen atoms, same reactants and products? As all the formulas are written correctly. So that one's okay, so put yes. So try that on the next one if you had trouble. Yeah, so you just write yes. If it's not okay, then we'll need to make a correction.
Oh, that's awesome.
Yes. So the sodium. Okay, and so you're trying to drop one hydrogen in Yes. And so what was the max amount? So draw another one and then check the one. Oh, I see what you're saying. You did the green and black. Yeah, so when you do number 4, you should correct the formula unit that's not neutral. Yeah. Nobody wants. Yes. Miss Freeman? Yes, ma'am. Is this one right? Okay, so number 2. This one looks like 2 7. So you did it. That looks great. You did it. Did the things. Yes, so it's so you're on the side, you draw sodium, and then hydroxide is the O next to sodium. Yes. Yes, H2 looks like Mickey Mouse. That just made my day.
Yeah, we just need 2
I can retire now.
Actually, no. Yeah. Oh, no, just.
Okay, you got it? No. Yeah, so now if you had to draw more to bounce it, then you should add those coefficients on your paper, right? Yes, sir. What is your time?
Oh, never mind.
she said it does. Hello. Alright, so on number 2, when you guys did it, is this what you had gotten? And so, what do I need to do? Can I just come up here and put 2 here and 2 here? No, this. Okay, so now I'll change the formulas. Y'all are doing good. I don't see anybody that did that. Do you need me to do 3 and 4 up here? How do you feel?
3 is kind of weird.
3 is weird? Okay. Y'all keep working and I'll put it up for you. Alright, so after you got to this point, Noah, were you not exactly sure what you needed to do?
Yeah, because I guess I kind of don't know what to do because OH is polyatomic ion, and I don't know how to treat it because it's a name.
Okay, so when the polyatomic ions aren't present on both sides, you just treat them like individual atoms. So just looking at this, you have 3 hydrogens on this side, and you only have 2 up here. So what do I have to do? You have to have another water. Right. Now, if I'm looking at this, it looks like I'm a little shy on what up here now. What am I added another oxygen.
Yeah, you're right.
Okay, so I need to add I have to add a whole other one of these, right? So I'm going to get another sodium hydroxide. Alright, so now I have 4 hydrogens, 2 oxygens. So what can I do to make sure I have the same on each side?
Add another sodium.
And I'm done. Okay. So here's number 3. If you're having trouble with number 3, and we need to write our coefficients up there. So check this before you move on. Anybody need help with number 4? You get a second to work on number 4.
Yeah, I thought I was. I was making it really hard. Just put this right here.
Seeing some good ideas in number 4. Everybody's come together pretty well. This is your two. They're like touching your mind, right?
Yeah.
I understand. No, that's fine. I totally feel you. I totally do. So, at this point, I don't want to kind of balance it all with that. That's what I'm trying to do. That's what I'm trying to So I'm going to quietly be working out number 4 as y'all finish, and we can talk about it. If you didn't make this so that you had 2 bromines, that was your first mistake. I saw that a lot on people's papers.
Oh.
What was the video? The changes magnesium
So most of you are finished with number 4, and this is, I saw you complete it and get it right. But just to make sure we're on the same page, if I count up my lithiums, I have 2 on my reactant side and 1 on my product side. The oxygens, I have the same amount. The magnesiums, I have the same amount. And I think we're maybe 1 shy on the bromine as well. So I obviously need more lithium, more bromine. So I can actually solve my problems, I think in 1 step. If I get another lithium bromide, which is most what I saw, but I just want to talk about it too. Do I have the same number of atoms on the reactants and product side now?
Mm-hmm.
So that's the thing. If you don't have your formula neutral for your ionic compounds, that'll cause you some problems. Somebody sent me a message last night, and apparently their paper, you could tell they had erased like 50 times, and they were like, I can't figure this out. And I think they had magnesium nitrate or barium nitrate, and they had 1 barium and 1 nitrate, and barium's 2+, and it didn't work out, and that was their issue. So you can see why I've been such a dictator about naming, because if you can't name stuff, you're not going to be able to balance stuff, and then next week we're going to add in a lot of math stuff on top of this. And so it just keeps, we have to make sure we catch each other along the way. All right, how do you feel about this now? Okay, so if I give you some of these, and if this was on the test, and this is what it looked like, would you be able to tell me that this was double replacement looking at the pictures? Okay. I think on the test when I did double replacement, I just did like red. Well, hang on. Let me show you. So I don't want to talk without you understanding me. On the test, it looks more like that. And so it's very clear where they just switched. Would you be able to tell me that was double replacement from the circles? Yeah. All right, so I think we're all straight there. So number 1 was good, and then 2 through 4, we had to change the coefficients, or in some of them, we had to change some of the formulas that weren't neutral. So moving on, balancing the equations. I'm going to switch gears now because I do like drawing the pictures. I think that's helpful, but I think also when you're doing stoichiometry, which is what we're getting into, or you're bouncing some more difficult problems, or you don't have colors, I do like the way I showed you guys with making a chart. I do like that. I think that is the end point, but I didn't want to do that until you understood what the heck was actually happening. So here's some things. Sometimes you might have to change coefficients a couple times. You need to balance elements in the compounds first. Balance elements in compounds first. If you have elements that are all by themselves, like if you have plus aluminum and aluminum's alone, or plus nitrogen, N2, all alone, you leave those to the end, and I'm gonna show you how that works. If you have a polyatomic ion that's together on the reactant side and together on the product side, you don't split it up. And be aware, sometimes there will be an element and it'll be mixed up. And so you might have oxygen and water, and then you might have oxygen and carbon dioxide, for example, with combustion. So anyway, there was one of these that was sort of tricky. I moved it in my PowerPoint to the last one. And I'll kind of make it something that you can sort of tune into if you want to. It might confuse some of you guys. So anyway, let's go ahead and get this started. Going by the rules that I just gave you, you want to save single elements to the end. I don't have any of those. I don't have any polyatomic ions. So what I'm going to do is just going to list them out. I'm going to do this one for you, and then I'm going to let you do the next one. So I have silicon, oxygen, hydrogen, and fluorine. Write them in the same order on this side. I always like to do oxygen last, but in stuff like this, it doesn't really matter. And now I'm just going to count them. 1 silicon, 2 oxygens, 1 hydrogen, and 1 fluorine. Over here, I have 1 silicon, 4 fluorines, 2 hydrogens, 1 oxygen. Now, the biggest thing people do is they'll play a game, and they'll go back and forth and back and forth and back and forth. No, just keep going straight down. Go all the way down, and then if you don't have it all bounced, come back up to the top. And I don't know, like, that's just like Miss Freeman's simple way to do things, but it works, okay? So, anyway, silicon's looking pretty good. Oxygen is looking less good. So, I'm going to put 2 here so I can have 2 oxygens on both sides. And when you're doing this, make sure, you know, this is with hydrogen. So, now I also have changed my hydrogen. So, I have 4 now. Alright, now, I did silicon, I did oxygen. I'm going to do hydrogen now. So, I have 4 hydrogen here. Well, on this side, I only have 1. So I'm going to put 4 here. That's going to give me 4 hydrogens and 4 fluorines. And I'm done. And that's it. Not too bad, right? So, anybody feel uncomfortable with the way I'm doing this? Okay. I'm going to get you started on the next one, and then I'll let you do it by yourself. So if we go to the next slide. Let me caution you here. Watch. Do I have any elements that are all alone somewhere? Carbon and what else? Yeah, so I'm going to put oxygen first, and then I'm going to put aluminum and carbon. Now, when you do this, it makes your life a lot easier. So try it this way. I'm going to let you finish and see how it works out, and I'll work it out for you. Yes, sir. When I say that they're all alone, right here, the carbon is not bonded to anything, and the aluminum is not bonded to anything. So if anywhere along the reaction you have something that's not bonded to something, it could be on the reactant side, it could be on the product side. You want to, if you put it last, it'll make your life a little bit easier. Yeah, no, it doesn't matter. So I could have put oxygen, carbon, and then aluminum. It wouldn't have mattered. So try this one. I think you'll find that it's easier if you'll leave the elements to last. And I know some of you guys can do these in your head, but there are some that you can't do in your head. And it's kind of like any skill. You know, you want to practice the right way, fundamentally, right? And then that skill will carry over. All right, so I touched my computer. How dare me? So it went away. So when I go and I count these, I have to start with 3 oxygens, 2 aluminums, 1 carbon, and on the product side, I have 2 oxygens, 1 aluminum, and 1 carbon. So when you have this little game of 2 and 3, 3 and 4, what you have to do where you can't like multiply them together to get you. Oh, if I multiply this by 2, it'll make this number. If you can't do that, you want to look for that least common multiple. And so what's the least common multiple between 3 and 2? 6. And so I'm going to try to get 6 oxygens. I'm going to do that by, put the 2 there. So that's going to change this to 6. That's going to change also this to 4. Hey, let me get this for Tim. It's a quiz. Jackson, just give me a second. No. Yeah. Just give me a second and I'll find it. So I'm going to change that to, I lost my place. that side's looking good. And I'm going to get 6 oxygens over here by making this a 3, and that gives me 6 and 3. So that's looking pretty good. My aluminum is a little bit off, so I'm going to add a 4 here. So I have 4 aluminums now. And now my carbon, I'm going to put a 3 here. Do you see how if I say those single elements to the end, it's just boom, 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 done? It's really nice, right? So that's how that goes. Any questions there? If you have this, like I said, 2, 3 is really common. 3, 4 sometimes happens where you have to multiply them to that least common multiple. So this one, do you see any single elements? Yeah. Do it just like we just did. And try this one on your own. All right, let me see. Even if it's diatomic, yes, it is still alone. Is that what you're asking?
There's a bunch of quizzes right here, but they're written.
Yeah, that was actually the practice that I gave out yesterday. Excuse me. No. I'll have them here. What happened was I remember I looked at Here you go. You can just sit right here. I'll just pull up the chair. It'll be fine. There you go. Okay. See a lot of people on the right track. I'm just gonna start the process of writing down the elements. So far, did you kind of start either with hydrogen or iron at the end? You could have flip-flopped, it doesn't matter. Did you do the something like that? That'll just help you. You don't have to, but it'll help you. So anyway, I'm looking at my oxygens. I definitely have 4 over here, but I only have 1 on the product side. So I'm going to change that by giving myself 4, and that will make my hydrogens 8. Next, the iron definitely can change that pretty quickly. And this hydrogen, if I want it to also have 8, I'll multiply this little compound by 4, and that will give me 8 hydrogen atoms. Okay? All right. Moving on. This combustion, this one is kind of tricky. I'm not going to lie to you. When you're doing this one, I'm going to kind of give you, I'll tell you what, I'm going to give you a choice. You can do this, and if this looks kind of crazy, you can instead, you can do that. If that doesn't make you happy, you can do this instead. You pick, okay? But pick one. So either do the C2H5OH or do C2H6. Oh, when you do combustion, I think I told you this yesterday, but I would spell the word choke. Spell choke. Spell choke. And if you get done with one, try the other one. Yes. You have to add it at the end. What happened? No, I mean, I had to rearrange your slides. The hardest one I found to be this one was this one. Does it in the workshop?
Oh, this one? Oh, yeah.
I think the one before that was harder.
The combustion one. I have a trick for combustion insects, and I'll show you. But I'll show you today. But I'll show you.
Alright.
Yes, sir. So the
Yeah, because I think I rinsed 3 times.
yeah.
Just because
I'm starting to wonder if leaving it like it wasn't easier.
the first time with 2, 3,
I'll show you the things.
I just learned you double it.
Was it easier?
You double it and then start finding
Combustion or trigger?
until they're even. So, yeah. It's like 1 through 5, don't mark it down and then you show.
Just keep going. You can do it as a well, if it equals out, we're gonna go.
Look.
I had to practice. I did,
Okay, I didn't know. If you get finished with the first one, try the other one. One is ethanol, like you put in your gas tank, and one is ethane, which is something else you can burn, but not an alcohol. So where's your little shot? You can draw it in your Bible if you want. Have your best interests at heart, okay? That's a bad idea. Did you get something? Yeah. Okay. These are tricky. I'm not gonna lie to you. They stink. I might have made your life hard with it. Yes, ma'am. So this is 3 oxygens and you have 3 oxygens. So you count them up. Yeah, you have to count them all together.
Do you do the same thing with you?
Huh?
With the C2H?
Yeah, so you have to, that would be 3 oxygens on the reactant side.
Yes,
Would you like me to do this? Okay. Combustion gets everybody, and that's okay. I'm gonna do this one as written. I don't know if this is more difficult or not. I thought it might be easier if you didn't have to count so many oxygens. All right, here we go. So to start out with, I have 2 carbons. I have 6 hydrogens. And I have 3 oxygens. Over here I have 1 carbon, I have 2 hydrogens, and I have 3 oxygens. Alright, so just start like normal. Just dive right on in and everything will be fine. Now, that's 2, but be careful now because now I have 5 oxygens, you see? On my hydrogen, I need more hydrogen, and so I'm going to put a 3 here so I get 6. And when I do that, what you're doing is you're not counting them all up. So watch me. So now I have 3, and then I have plus 4 is 7. Now, over here, I have 1 oxygen plus 2 oxygens. But I need to have 7. 1 plus what is 7? And I can do that easily by taking this 3. Is that too ninja for you? Is that too ninja? Is the other one harder? Yeah, shake said
I
yes.
did it a different way, but mine's still balanced.
Okay, so if you did it a different way, tell me your coefficients.
2, 6, 4, and 6.
Okay, so do you see how 2, 6, 4, and 6 are all divisible by 2?
Yeah,
And
I
so
realized that.
when you see that, you would have to divide them all by 2, and then you'd be okay. Brendan? Sure? Do the other one. I hope I didn't give you something too hard. I tell you what. With the other one, would you like to see my bouncing combustion trick?
Yeah.
Okay. Okay, I will show you the things. Somebody said their head hurt.
Yeah, that was Jaleel.
Fair enough. All right. Now hear me out. When you do combustion, what are always your products?
H2O and carbon dioxide.
Okay. And how many carbons does carbon dioxide always have?
1.
And how many hydrogens does water always have?
2.
Now watch. Okay. I know right off the bat, what is this coefficient right here going to have to be?
2.
And then right off the bat, if this one gets doubled over here, do you understand how I figured out that 3?
Mm.
Yes. Because 2 times 3 is 6.
Now we can kind of see where we are. Now, what the issue is, what y'all were doing, if this is like above your head, don't worry about it. I just wrote your test. It's okay. It's okay. Now I'm going to take care of my oxygens. I have 3, and then I have 4, which is 7. Now, I can't come over here and say 3.5, can I?
No.
But listen to me. Listen to me. If I did do 3.5, would everything be cool? Guess what I can do now? Remember how he just divided all his by 2 because he messed up? What can I do to fix this? I multiply all of by 2.
7, 6. That's what we did.
So 2C2H6 plus 7. See what I did? I'm multiplying by 2. 6 H2O.
That's what I did.
Or you can sit there for a really long time. Whichever one you want to do. Do you want to? He said I'll still do the other one. I love each other. So there's something when you're taking your test, it's multiple choice, and don't freak out. Combustion is really tricky, and I realize that. So don't be sad. Now tomorrow, we're going to do like the whole class, whatever we don't get to today. We're going to practice. Like you have practice connected to this. So like if you're like, I need to do that some more, you're gonna do it some more tomorrow, and then we're gonna make our lab on Thursday. I don't like to send stuff home until you get it, and I don't feel like you're ready. So, well, let's finish the counter point and see where we are. Do you want to try another combustion just without me? You want to try a special trick?
Yes.
Just try it anyway. Yeah, try it on your boards. You can try it the show way, or you can try it my trick way. Your choice. Yeah, so it was like bouncing practice and then reactions practice. And then there was a answer and it's on the back of the answer. It's on the back of it. So then you're good. Give yourself some space to write your coefficients.
Does that say displacement?
It's like a reactive reagent. Wait, is this
Okay.
so your test is multiple choice, and so the multiple choice is like, what's the right coefficients? But there's like 2 questions. There might be one balance. Try it. You're okay. Give yourself some. Yeah. You're okay. And if I was doing this, I would give myself a little bit of. You know, it's all right. Yeah, you're good. No, I saw it hurt. So try this one and see what happens. That trick is. Did you do it? Did you divide like you bounce it out by this and then you make that back? Yes.
Yeah, that's only like I feel like. Change this. It's just weird.
Produces what is the I'll tell y'all what I mean. I know that. Is this right? This is almost there. Almost there. Yes, and then that is right. So did you do the same as she did? What number is this? What is 3? So that takes us 3 times 2 is 6. Look, so this is 6 plus 1 is 10. It's the adding problem. Did y'all do it? Is it the worst thing ever? That's my face. Okay. So no question mark instead. Are you proud of that? There we go.
Oh no, that's hers.
You got it? Said it was right. So
So good and stuff.
how are you getting 6 cards over here? That's what you promised. Whatever. You're okay. Alright, some of y'all are close. I really want you to like get that. Oh, I did it. So let's continue for just a second. If you've had this one finished, try the next one. Which one is the next one in your PowerPoint? Let me see.
Ammonia.
The next one in your PowerPoint is tricky. Skip it and go to the aluminum phosphate one. Try the aluminum phosphate one. You see aluminum phosphate?
Okay.
If you're feeling comfortable, you can go to right now. See? You did it. Yes, I like it. Hello. Okay, so you could have written out the CHO and hauled through there. Now watch me. Watch me do this. I feel like I'm on the right phone. Is that a thing? No. Okay. I need to get out more. So this is how I do the combustion. You ready? Carbon is same as the carbon. This one's half as much because it gets multiplied by 2. Now I got to take care of my oxygens. I have 6 plus 4 is 10. That's a 5. Done. Works every time. And sometimes when you go back to fix your oxygen, it'll be that odd number and you just have to multiply all by 2. But you can totally write it out, and if you do write it out, write choke. Okay? So we're going to go on to the aluminum phosphate one that's in the PowerPoint. Skip that one. Skip that one. Let's go to this one. So if you're feeling really comfortable, there are some practice attached that you can be working on. After this one, yeah, you can try that one. There's 3 more, 4 more. This one is very. This one actually isn't hard at all. You can't really judge them by what they look like.
It only has like 1 number.
Yeah, it's pretty straightforward.
Yeah, I was like, I remember you saying that it didn't work. Yeah. Yeah.
That's why I made you memorize your polyatomic ions. Because now when you see that, oh, it's phosphate. And then also, do you see how I did sodium last? Do that. Do that. Don't break up your polyatomic ions, and if you have a single element, put it last. That'll make your life much easier. You're drinking more, huh? I'm sorry? Hey, you can try the next one. Yeah, skip that one. I don't even, I think some of y'all, I'm just going to get you to like cover your eyes on it. It's just not, it's not, you know what I mean? Like, you feel good, and there's this one crazy one that makes you sad.
Doesn't that method that you showed us work for like just about any?
No.
Why? Well, that was
It works for combustion. It works for combustion. You said we could skip this next one. Okay. Is that it to that one? Is that it? We haven't tried it. Alright, check your answer to this first one and I'm going to erase it. Feeling okay about that? That one was pretty straightforward. It's kind of anticlimactic, I'm not gonna lie. Anticlimactic. There we go. So try this one now. Do you have any single elements? No. Do you have some polyatomic ion to work? Do you have a polyatomic ion? Okay, so put that one and leave it all together. So you have 2 ions. Okay, so 3 carbons. So when you see the polyatomic ion, just think of like one circle. And that's how the best way I can tell you is actually all together and it's not that easy. No, see, the only time you're going to have a number that goes to both of the legs is together. And it goes.
Yeah. That's why I was like, just do it.
Yes.
It's easy. What was that?
Yes, ma'am. Right here. And I have that MP, so if I contact, I have it on MP. Y'all send me. Alright, check this one. Happy times? Okay. Have any single elements? No, do I have a polyatomic though? Yes, I do.
So basically, if you have a big one, the little ones, it's decomposition. If you have two little ones, and you do a big one, it's synthesis. Don't doubt yourself. Just a bit. Good. Switch there. Switch. I'm trying to think of the big word to use, but smart. You sure?
Alright, check that one. And then this was the last one. Okay, so I'm going to come back to this one in a minute. I want to show you. Hey, have a nice day. Let's make sure we know our types. On the test, I would say out of the 50 questions that I had given you guys, 10 of them are like, what kind of reaction is this? And some of them have the models, like the little atoms and particles, and some of them have formulas. So I see some of you guys are finishing up the practice. Give me your attention. Thank you. I appreciate your hard work. But just to make sure we're all on the same page. Synthesis, I'm going to take two substances, and they're going to combine to make one substance. And so you can tell a synthesis because you'll start with two things, and you'll end up with one. That's pretty straightforward. So if I have a music synthesizer, it has all the sounds put together in one box, right? And so I have all these things put together. Decomposition, decomp means to break down. And so I have one substance, and it breaks down into two. And you can imagine that this is just a decomposition in reverse. And then this decomposition is a synthesis in reverse. Do you see that? So when we start talking about equilibrium later, reactions don't just go one way. They go two ways. Isn't that fun? Don't worry about it. So we'll get to that later. Single replacement. And so here, if I have a metal, it'll switch for the metal. If it's a non-metal, I can tell that A is a non-metal. Can you tell that A is a non-metal? Can I tell that because I'm a magic fairy?
No.
No, and the reason I can tell is because when I have this switch, A is a metal because it's first in the reaction, and I can tell C is a non-metal because it's second, metal then non-metal. That's really not anything crazy, but I thought I would just bring that out to you. And then here, I have a metal, switches for a metal. Okay, so you wouldn't want to put, like, let's just say it together. If you have something on your paper like that, and you go to try to balance your charges, that ain't gonna work. Okay, so we make ionic compounds by making a neutral charge. So I can't do anything with +1 and +3. So aluminum or sodium aluminumide, see how that'll sound right? So that's how you can check. Remember, I made a little note there. The remember part is metals are cations. Replace those metals or cations. Non-metals or anions replace anions. That's really simple, right? If you come out of this with, like I said, two metals stuck together, sodium, magnesium, and like, well, how does that work? Or you get something like chlorine and chlorine together, and then you have a single metal. Like, you know that you didn't do something along the way correctly. So that's single replacement. And then double replacement, same idea goes. You're going to make sure you switch your metals for metals, non-metals for non-metals. And so you're going to have a compound, and a compound makes a compound and a compound. On that single replacement, you would have a single element somewhere. And it would make another single element in a compound. So that's the difference. So two switch. And then combustion, any hydrocarbon typically reacts in the presence of hydrogen, and it gives you water and carbon dioxide.